Okay, let us go on. So you can see the page 3. You can see the page 3. You are to put the base or pour the base. Put the base, that is Bn, because you have to follow instruction. You are going to be given some set of instructions, so make sure you follow it. You have to put Bn into the burette, because it is there. You don't pipette acid. So you pipette, they will not tell you it is acid. Sorry, if it is An, then there is a mistake there. So you have to put An, not Bn. Put An into the burette until you get to the 0 mark. So the burette is usually graduated from 0 to 50 centimeter cube. Add the acid, that is An, into the base drop by drop until you notice a color change, and it signals the end point of the titration. And take note of the volume of An used. Then perform the titration 3 times to obtain consistent or concordant titer. And make sure you round up your titer values to 2 decimal place. What I'm saying is, immediately you get to the 0 mark, that will be your initial reading. So you start putting the acid, that is An, little by little into Bn. Bn is already you already pipette Bn, that is 25 or 20, and you have added 2 to 3 drop of methyl orange indicator. So you can see the diagram. You can see your conical flask, that is 2 centimeter cube or 20 centimeter cube or 25 centimeter cube of Bn plus 2 to 3 drop indicator. So that is that. So you are going to obtain you are going to do it 3 times before you end the titration. So going to page 4 will be your final reading. You can see the table of readings. Don't use my own. That is, after you perform your own experiment, you are going to have this. Volume of pipette that I used is 25 centimeter cube. Your own, maybe the one your teacher will provide for you, is 20. So make sure you write it there, the volume of the pipette that was used. So when I started the titration from the 0 mark, you can see it in 2 decimal place, 0.00. My final reading was 9.40. I pour it away and top it up again. So I've used the acid, so I add more. I top it up again to 0. Then my reading was 9.41. The color changed again. Then I top it up again to 0. Then I have 9.40. Then volume of An used, how do you get it? It is final minus initial. So 9.40 minus 0.00 will give you 9.40. At the end of the day, you calculate the average titer. You can see it. Average titer is the same thing as average volume of An used. So we have 9.40 centimeter cube. Then the equation of the reaction is also shown. Sodium carbonate, that is the weak base, reacts with HNO3 strong acid to produce salt, NaNO3, and water. So then we have to make sure we balance the equation of the reaction. We have to make sure we balance the equation of the reaction. Then going to page 5. You can see page 5. Acid plus triosocarbonate 4 usually produce salt and water. An acid is a substance that reacts with a base, e.g. triosocarbonate 4, to produce salt and water. Not just salt and water, salt plus water plus CO2. So the reaction is used to determine the concentration of an acid if that of the reacting base, e.g. Na2CO3, is known. We have a sample of strong acid, that is tetraososulfacic acid, H2SO4, HCl, and HNO3. We have weak acids, you can see it, ethanoic acid, you can be asked. Weak base, you can also see it. Then going to page 6, I believe you can see it clearly. Likely Neco 2022 chemistry practical question. So A is a solution containing 6.3 gram per dm cube of HNO3. B is a solution of Na2CO3. Put A into the burette and titrate it against 25.0 centimeter cube portions of B using methyl orange as indicator. Repeat the titration to obtain consistent titers. Tabulate your burette readings and calculate the average volume of A used. You can see my equation of reaction clearly. B is the Na2CO3, A is HNO3, and you can see I've balanced the equation. I've balanced the equation. So the number of mole of acid is 2 and the number of mole of base is 1. That is, number of mole of A is 2, number of mole of B is 1. You can follow the way I've solved it. So B now, from your results and information provided above, calculate 1 concentration of B in mole per dm cube, and you can see it. You can see the way I solved it. So follow it that way. Then going to page 7, you can see the remaining solution. You see the remaining solution clearly. You can see it there. You can see it clearly. I believe you can see it. So I'll still do it in such a way that you can be able to view it clearly. Yes. So make sure you are mindful of your units, and there are some formulas you have to know offhand. Concentration in mole per dm cube is equal to concentration in gram per dm cube over molar mass. And make sure you put units. The unit of molar mass is gram per mole. It can make you to lose mark. So make sure you put the unit. Make sure you put the unit. You can see it. I believe it is clear here. Concentrating on it. You can see it clearly. So now we will move to qualitative analysis, which is the second part